Hello friends, I hope you all are doing well. So we are back with another video, and in this video we are going to solve a program and a question named magical number. Let's see the description of this program. So you can see here the name magical number, and let's read the description. So it's saying that we have to take a number, any positive number, integer, and we have to replace that number with the sum of the squares of its digit. We can see the example given here. Here the input has been taken 19, and we have to do the sum of a single digit. Okay, so square of 1 plus square of 9. So it's equivalent to 82, and we have to repeat this process until we get 1. Okay, so we have to repeat this process until we get 1, and if we don't get 1, then we have to print no. Okay, so let's see another picture here. What output should we give? Okay, so we can see here that we have to print yes if it's a magical number, and we have to print no if it's not a magical number. So we have read the description of this problem, and we know what we have to print. So the problem here arises that if we get 1, then it's simple, we will print yes. But if we don't get 1, then it will go in an endless loop, and we cannot simply print no once and break the loop. So let's see how we will solve it. So let's take an example of the greatest 6-digit number, which is 999999. So if we do square of its single digit and add, then it would sum and give a number which is 729. And again, if we repeat the same process, we will get a number 134. And again, if we do the same process on this number, and we will get a 2-digit number which is 26. And again, after repeating, we will get 40, and again we will get 16. So we can see that this loop is increasing continuously. So I don't think it's the right way. Let's start from the base number. We will start it from a single digit numbers. Let's start from 1. For example, if we take 1 and if we square it, then it's equivalent to 1. Okay. So we can directly print yes. So okay, for 1 it's directly 1. Let's take example of 2. If we take 2, then it will square up for 4, and 4 will go for 16, 16 will go for 37, and 37 would go for 58, and 58 would go for 89, and 89 would go for 145, and 145 would go for 42, and 42 would go for 20, and again 20 would result in 4. I'm sorry, 4. So we can see that again it's coming back. This 4 is again coming back here. So we can see that if any number, okay, let's move forward. I will explain you the logic at the end. Let's check for all the base case. Now let's take a number 3. If we take 3, then it will square up and form 9, and 9 would go for 81, and 81 would result in 65. 65 would go for 61. Okay, 61. And 1 minute. No, it's 61. Okay, and 61 will again go for 37. Okay, 61 is going for 37. So we can see that again this number, this 37 is meeting here. So after 37 it will go for 58, 89, 145, 42, 20, 20, and 4, and again it will go in a loop 2. So okay, we are trying to find a loophole in it. So let's check for from 1 to 9. We will check the number, and then I will explain you. So let's go for 4. 4 will go sum up to 16. 4 4 is 16, and you can see 4 would square and it would go for 16, and 16 would continue this same process again repeating. Okay, let's go for 5. 5 if we take, then we will get 25, and 25 would result in 29, and again if we repeat we get 85, and we can see somewhere we got 85. No, yeah, if we square its digits and add it, then we will get 89, which will again form a loop. You can see this 89, it will join here and it will continue this process again, and this 4 will again come again. This portion will repeat continuously. Okay, so this was for 5, and for 6, 36, and if we sum it we get 45, and again if we add it we get 41, and finally we get 17, and again we get 50, and this 50 would form 5 5s are 25 plus 0 0, it will go for 25. Okay, so we can see this again, this 25 is giving, it's joining here. Okay, so from 29 it will go here till 89, and from 89 again it will go here, and it will form a loop. Okay, so that was for 6, and for 7 let's see, it will go for 49, and 49 would go for 97, and 97 would give result to 130, and it will form 10, and ultimately it will give 1. So we can see that for 7, if any number that comes begins with 7, we will see it is giving a final value 1. So this 1 would repeat and come here, and ultimately for 1 we will directly print yes. So that's not a big deal. So this both 1 and 7 are exception case, and we will use the same logic for solving this program. So let's quickly complete for the last 3 digits. So for 8 we will see if 8 will give 64, and 64 will give 52, and you can see this 52 and this 25, this both are not much different, only we have to square the digits and we have to add, and ultimately it will give the same result again 29, and 29 will form a loop, and it will go for this in this series. Okay, so I'm sorry, in this second number series. So this was for 8, and for 9 let's see, 9 9s are 81, and I think we encountered 81 somewhere in this program. Yeah, we can see for 3 it's coming 81, and 65 61 37, and again this 37 would form a loop here, and it's continuing. Okay. So we can form a logic that if any number whose sum is equivalent to 2, or either 3 or 4 and 5 6 and not 7, and this 8 and 9 whose sum is equivalent to 9 8 and these numbers, then that would definitely go for a continuous loop. So we can add if statement, like if any number which is resulting into 9 or 1, no, sorry, not 1, 2, 2, let's see these numbers, what are those? Okay, so these are 2 3 4 5 6 8 and 9, then we can directly end the loop, and we will print no. And if any number whose sum is resulting into 1 or either 7, then we will directly print yes for it. So this is the logic for this program, and let's make the program. So let's quickly include the header file, hash include stdio.h, and let's declare the main function, and let's initialize the variables, and we will take the test cases. We have to run the test cases, and variable n for the number, and r for the reminder, and sum for finding the sum, and we will initially give it the value 0, and let's scan the value. I'm sorry, let's see here, scan address of n, and after taking the input, after taking the, I'm sorry, this is not n, this is t, because we are scanning the test cases, and after scanning the test case we will run a while loop. So we will write the while loop in this manner, while t negative, and inside we will scan the n value, the number we will scan scanf %t ampersand n, and we will here also will declare the sum equals to 0, because every time after every new number we have to make this sum equals to 0. So this won't cause affect the program, and internally we have to declare another loop in order to get single digit. We need one digit from each number, and we will add this condition, and should be greater than 0. And let's take the reminder equals to n modulus 10. So using this we will get the reminder, and let's sum it, sum plus equals to we need to square the reminder, means each digit which we get. So we will do this, and then finally we will decrease the value of n by 1 decimal point, so n/10, and then yeah. So now using this loop we will get the sum of the number. Okay, and here we will find we will test the condition here. If the sum is equals to we have discussed here now, this, if the sum is equals to 2 3 or the following number, then it should print no. So we will go here, and we'll add the condition here. Here the sum, if the sum is equal to 1, or sum is equals to 7. We have seen here that only these two cases, either 1 or this 7, is resulting into 1. So we will add this condition, and if the sum is equal to 1 or either 7, so we will directly print. We will print here that printf that yes, we will print, and it should go in a new line. And actually, there's a problem in this program. If we initially we are trying to find the remainder, we are trying to find the remainder, and we are adding it. And we don't want this sum to go into the if condition until the n is becoming 0, because after the n is becoming 0, then only we are checking the sum. Okay, so we will add here one more condition. If n is equals to 0, okay, and sum is equal to either 1 or either 7, then it should print yes. And after printing, yeah, so we need to now check the else condition. So else, in else if we will add else if. I will let you know why. Else if I'm sorry, I forgot to add the condition here. Else if n is equals to 0, again we will check here sum, and if the sum is equals to 2, and 2, 1 minute, I'm sorry, either 2, and we'll copy this, Control C, and we'll paste it here. Okay, the sum is equals to either 2 or 3 or 6 and 4 and 8 and 9, and I think I missed out 5, I guess. Yes, I missed out 5. If sum is equals to 5, then we know that the sum would go in an infinite loop and it won't end. So directly if we encounter the sum equals to 2, 3, 6, 4, 8, 9 or either 5, then we will print that print no as per the given question output. So we'll print here no and a new line, and yes, so we have done this. And if at all none of these test cases, I mean these conditions is passing, either if or else, then we will simply assign, we will go in the else part, and we will change the value of n. Now we know that the n is equals to 0, but still we want to run the loop because we still none of these conditions have been satisfied. So we will change the value of n should be equivalent to sum, because we know that this sum should be again we will take single digit and we will square it and then we will add it, and it should go up to just either if either of these conditions are satisfied or not. So we will change the value of n, it should be equivalent to sum, and the sum should be initialized, I mean it should be equated to 0, because we don't want the previous value to interfere in this program. So our program is ready. You can see we have made it, and let's try to run it. 1 minute. I think I have made an error here, so it should not be the else part, it should be else if, and here should be a condition if n is equals to 0, because we don't want the n value to change after every iteration. We want to change it only if n is becoming 0. So if n is equals to 0, we will change its value. And previously I forgot to add this semicolon here, and after rectifying the errors, this is the complete program. You can see this. So let's copy this program. Sorry. So let's copy this program completely, and let's paste it in this website here. And so you can see this program, this is exactly what we wrote there, and let's test the compile and test what's the output. So that's a positive sign. The sample tests have been passed, and let's submit it finally. Oops, what happened? What's valid? Okay, so you can see that we have got one error. It is partially accepted, and the rest 3 are accepted. So we got 75 points. So our score is 75. So let's. This was a quite good program. So I hope you understood the logic of this program. So this is what I wanted to explain you in this tutorial.
So thanks for watching this, and if you are new to our channel, then please subscribe our channel Techno and help us to grow. And if you need any solutions for any competitive programs, then you can just let us know in the comment section. We will definitely make a video on it, and just subscribe our channel and help us to grow. Thank you, friends.